ground. And it says, I really can't measure it because it's reflecting on grass, and that's scattering all the signal. Whereas when I bring it over the cloth, you see how good we get a good reflection, and it tells us. So we could use this to say where the edges of the table are and pretend this is a kilometer long and use this as a way to design aeromagnetic surveys. So airplanes flying over the ground to measure the rocks underneath. For example, if you look out over here, I ask you as a geologist, what are the rocks? And you say, I don't know, that's green grass. I can't tell what the rocks are. I need some geophysics to help me understand it. So I'm gonna fly my little airplane along. Now I've got the total magnetic field. Look at that beautiful anomaly. And another in the 3 components. So this line is the total field, how big the magnetic field is, and that changes as we go over rocks of different susceptibility. And this one down here is the 3 components. So all the 3 components of the magnetic vector, the magnitude of each one of those 3 components. So I need a pilot. Who wants to be my student pilot? Can you fly? We have our videographer here, so I don't want to interrupt him. And then we have our geophysical interpreter. Who wants to interpret? Can we get, oh, we're going to use pink now. We're going to use pink. So if you stand over here and he stands here, what we're going to do is, and the rest of you can shout when there's an anomaly, is you've got to fly really close to the surface. Okay? And where there's an anomaly, she's going to make a mark. Okay, so there was an anomaly here, a little one. Okay, so there we go. We can afford chalk. Okay, so carry on. So you're flying like an airplane, back and forth. Anomaly? You see that anomaly? Everywhere you find an anomaly, you want to make a mark on the chalk. Okay, and then keep going. You want to go back and forth. Back and forth. There's an anomaly. Good. Okay. And keep going. Oh, there. That's it. Back and forth. That's it. But you got to move the next line over. The airplane moves back and forth.
Something.
Okay, there we go. Okay, and obviously when we're flying, we don't, draw spray paint on the ground. But what we do is we collect the data and we make a map of it. And then we interpret that map. And we would have all these magnetic anomalies to interpret. Okay, keep going, keep drawing. Okay. Oh, that looks like a really big one. Okay, so so what we do is we use this to design an aeromagnetic survey. This is an exercise to design aeromagnetic surveys. How fast we fly, how close together our lines are. Do we have lines in this direction or this direction? Because these are expensive decisions. When you think about how much it costs to fly an airplane for hours and hours and hours to fly the whole country. So we actually, were you guys up in the seismic lab already?
Yeah.
Did you see that beautiful image at the end of the hallway, all those colors? That's magnetic data for the whole country. This is exactly what was done, except with a real airplane, was flying the whole country to map those beautiful magnetic images, okay? And so that's our Pocket Lab. Just show us our Pocket Lab so I can get a picture of you with it. There we go, Pocket Lab. They love this. They're actually a really great group of people. Okay, so now we've got all kinds of lines and dots on here. So, no, you're not done yet. What we've done is we've only marked out where the anomalies are, but of course the Earth has continuous structures. So do you see anything here that makes a long line? Where would you interpret a linear feature? Maybe right there? Okay, do you want to draw that in? Here, take the, yep, go ahead, draw it in. This is washable. Okay? So there, you've interpreted a linear feature. And one type of rock that has linear features is something called a dike. If you noticed, maybe on that big map, there were some long linear features. And dikes are often associated with water. So because they fracture the rock and they themselves are often fractured, they often contain water. Now I think you might do some other interpretation. I think we had, where was it? Is it over here? Okay, you see we've got something really big here. Okay, so let's draw maybe a little circle there, because I went back and reflew because I felt like our pilot didn't do things quite good enough. Also, I know where things are. Okay, so, and then we have a few spurious points that we're not sure of. Okay, maybe we have a confusion about it, or somebody left some trash on the ground or something. Okay, so this is our geophysical interpretation. We've got a few scattered anomalies, we've got a linear feature, and we've got a nice big circular feature. So shall we look at what we've got? So let's have the big reveal, if I can find the edge. Okay, so nice job. We got our linear feature, and we got this something here. And let's see, for example, what this is. And if you want to do the honors. No.
Oh, the other
So you
side.
have to hold it by this so it can freely swing. And then you hold it on the side. Okay, now it's pushing it away. Turn it around. There we go. Now it's attracting it. Okay, so it's really magnetic. This is a piece of real magnetite ore from the Bushveld complex. Okay, and you can see, look at all the little crystals in there. Do you see all those crystals?
Try to
Oh,
hold
yeah, I
it up
see.
with the pen, with the
Yeah, it will hold it. It's actually strong enough.
Oh, on the side.
Yeah, let go of it. Wow, look at that. So this is the magnetite ore in this country is
the
incredible.
rock at the bottom.
It's 90%
and then
magnetite,
the magnet at the top.
and
So
this
Like
ore
this,
body,
let's look at
this
it.
is
It's
from
gonna-
the main
Maybe little
magnetite. I think it's too heavy for that.
I won't.
Just wrap your head around this. The main magnetite layer in the Bushveld is 6 meters thick. Imagine this rock, 6 meters thick. That's like half the size of the building. And it extends laterally for about 200 kilometers. That's a lot of magnetite. Okay, that's a huge amount of magnetite. So that ore body, which this is from, is mined not for the magnetite, although we do get some iron out of this. We mine it for vanadium, which is an element we use for making high quality stainless steel.
Yeah.
Okay, so high quality stainless steel